Picture this. It's around 15,000 years ago, somewhere on the coast of what is now New Zealand, and a group of ancient humans has just arrived on these islands for the first time in the history of any human being arriving anywhere. They're tired from the voyage. They're hungry. And then they see it. Standing in a clearing, not running, not hiding, not doing anything that acknowledges the presence of the most successful apex predator this planet has ever produced, is a moa, a giant flightless bird, some species reaching over 3 meters tall, built like someone took an ostrich and asked it to bulk up significantly, just standing there. Looking at them, if birds can be said to look at anything with focused attention, which in the moa's case appears to be an optimistic description of what its cognitive processes were managing. The ancient humans look at the moa. The moa looks at the ancient humans, or performs the moa equivalent of looking, which apparently didn't include any meaningful processing of the information that these small bipeds might represent a problem. The ancient humans have spears, accumulated hunting knowledge, social coordination, fire, and thousands of years of cultural wisdom about how to handle prey animals. The moa has legs, and feathers, and a confidence that was, given subsequent events, quite significantly misplaced. What happened next was approximately as fast as you'd expect when one party has sophisticated hunting technology and multi-generational predator experience, and the other party has never, in its entire evolutionary history, encountered anything that walked upright and through things. The moa was not fast about updating its threat assessment. The moa was not fast about anything, as it turned out, and within a few centuries of human arrival in New Zealand, the moa was gone. Every species, all 9 of them, gone. So here's what this video is actually investigating. What is the dumbest animal ancient humans ever encountered? And what does animal intelligence, or the dramatic absence of it in certain contexts, actually mean ecologically and evolutionarily? Because the moa's apparent failure to appreciate its situation raises an interesting question about what cognitive capability animals actually need in their environments, why some animals seem spectacularly unprepared for novel threats, and what the accumulated encounters between ancient humans and various cognitively limited animals tell us about the relationship between intelligence, evolutionary history, and survival. Stick around because the answer involves some animals that will make you feel deeply concerned on their behalf, some evolutionary explanations that reframe what dumb actually means, and a reflection on what ancient humans learned from these encounters that shaped their understanding of the animal world. Start with a critical reframing because the word dumb applied to animals requires immediate and careful qualification before this conversation goes anywhere useful. Intelligence in animals, as we established in our animal intelligence video, is domain-specific, calibrated by evolution to the cognitive challenges that species faces rather than representing a general-purpose capability uniformly applied across all possible situations. An animal that appears spectacularly cognitively limited in one context may be remarkably well adapted to its actual ecological challenges in ways that look like intelligence when properly measured against those challenges. Calling an animal dumb, in an absolute sense, misunderstands how animal cognition works. What we're actually identifying when we describe certain animals as dumb in the context ancient humans encountered them is something more specific and more interesting. Animals whose cognitive apparatus was calibrated for an evolutionary environment that did not include the type of threat that ancient humans represented, making them appear profoundly unaware in those high-stakes situations. The MOA wasn't cognitively limited across the board. It was cognitively limited in exactly the way that mattered most at exactly the wrong moment in its evolutionary history, and that limitation, combined with the novelty of the human threat, produced outcomes that look, from the outside, like spectacular stupidity. Proceed to the actual candidates for this title, because there are several remarkable entries worth examining. The dodo is the most famous example, and its fame is unfortunate because it has been systematically misrepresented. The dodo was not stupid in any meaningful biological sense. The dodo was a pigeon that had spent approximately 26 million years of evolutionary history evolving on an island with no mammalian predators of any kind, which produced a pigeon-derived bird that had lost flight capability because flight costs metabolic resources and provides no benefit if nothing is trying to eat you, that had grown substantially in body size because island gigantism is a common evolutionary outcome in the absence of predation and resource competition from large mainland animals. And that had consequently never developed the suite of predator avoidance behaviors that continental animals maintain because continental animals face predators constantly. When Dutch sailors arrived in Mauritius in the late 16th century, they encountered dodos that didn't flee from humans, didn't recognize clubs as threats, and were interested enough in human visitors to approach and investigate them. Dutch sailors described this as stupidity, and the description has stuck in popular culture for 4 centuries. What it actually was is the behavioral profile of an animal that had never needed those threat recognition behaviors in its entire evolutionary history, and therefore had never developed them through natural selection. The dodo was cognitively appropriate for the environment it had evolved in. It was catastrophically unprepared for the environment it suddenly found itself in when humans arrived with clubs, rats, pigs, and dogs. Ancient humans arriving in island environments worldwide encountered this same phenomenon repeatedly because islands consistently produce animals with reduced predator wariness due to the absence of mammalian predators during the island's isolation. The behavioral profile of island naive animals, approaching humans, not fleeing when approached, not responding to novel threatening stimuli with flight, shows up across bird and reptile species on islands throughout the world that experienced initial human contact after long isolation periods. Ancient Polynesian and other Pacific Island peoples arriving on successive island chains encountered bird populations with these characteristics repeatedly, with outcomes that contributed substantially to the pattern of bird extinctions documented archaeologically across the Pacific. The moa is the most dramatic scale example, because the largest moa species was among the largest birds that ever existed, and its behavioral profile was correspondingly dramatic in its lack of threat response. Ancient Maori hunters who arrived in New Zealand approximately 700 years ago encountered a population of approximately 60,000 to 100,000 moas that had never seen a human being and apparently could not map the experience of seeing one onto any existing cognitive category associated with danger. Moa hunting appears from the archaeological record to have been straightforwardly efficient, with moa remains found at early Maori sites in large numbers and with processing marks consistent with systematic butchering rather than difficult predatory encounters. Within approximately a century, the moa was extinct. The Haast's eagle, which had evolved to be the apex predator of New Zealand and hunted moa, went extinct shortly after the moa did, which is a different kind of cognitive failure story. The Haast's eagle was presumably quite capable cognitively for its actual ecological role. It was just dependent on a prey base that itself had no capacity to persist following human contact, and the eagle went down with the moa because its prey did. The kakapo, which still exists thanks to conservation efforts and is one of the most beloved animals in any discussion of unusual birds, deserves extended attention here because it illustrates the island naivety problem in a living animal in ways that have been extensively documented with modern behavioral analysis. The kakapo is a large, completely flightless parrot that evolved on New Zealand in the same predator-free environment as the moa. Unlike the moa, the kakapo survived into the modern period, though only through intensive human conservation efforts that have prevented the wild population from going extinct. Kakapo behavioral characteristics that reflect their predator-free evolutionary history are extraordinary and occasionally spectacular in their apparent cognitive disconnection from threatening situations. When approached by a potential threat, kakapos freeze. This is their primary anti-predator behavior, standing completely still and relying on their brown-green cryptic coloration to blend into the surrounding vegetation. This strategy works excellently against predators that hunt primarily by vision and cannot smell, which describes the aerial predators like eagles that were the kakapo's historical main threat in New Zealand. It works extremely poorly against dogs, rats, cats, stoats, and humans, all of which navigate by smell as much as by vision and find a completely motionless kakapo standing still in front of them not especially challenging to locate or approach. The kakapo's famous interactions with researchers and conservationists have produced some of the most entertaining and simultaneously poignant wildlife footage available, including incidents where kakapos have attempted to mate with human researchers' heads, which is either charming or confusing depending on your perspective, but clearly demonstrates that kakapo sexual behavior recognition systems are not finely calibrated for distinguishing between kakapos and cameras, or apparently human heads. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. The kakapo doing this is not being stupid in any absolute sense. It's following behavioral programs that worked perfectly well for millions of years of evolution in an environment that produced no situations requiring better discrimination. The problem is the environment changed dramatically, and the behavioral programs didn't. Ancient humans encountered the kakapo and related naive island birds throughout the Pacific, and the practical experience of finding birds that not only failed to flee but sometimes approached humans had significant practical implications for ancient food acquisition. Islands with naive bird populations provided relatively easy protein access for arriving human groups, which contributed to the attractiveness of Pacific island colonization as a subsistence strategy alongside the fishing and agricultural capabilities that Pacific peoples developed. The cognitive limitation of island birds from the human hunter's perspective was a practical resource. Move from birds to some other candidates worth examining. The American bison, not for lacking intelligence in any significant way, but for one behavioral characteristic that interacted badly with human hunting technology. Bison have a strong herd-following instinct that causes individual bison to follow the movement of the herd even when that movement is taking the herd toward danger. Ancient hunters on the North American plains exploited this characteristic extensively through the drive and cliff technique documented in the archaeological record, where groups of hunters positioned themselves to funnel bison herds toward cliff edges and exploited the herd-following instinct to drive large numbers of animals off the cliff simultaneously. The bison following the herd in front of it toward a cliff is not cognitively limited in an absolute sense. Bison are reasonably intelligent animals with complex social structures and good individual threat recognition in normal contexts. The herd-following instinct is adaptive in most situations because solitary bison separated from the herd face elevated predator risk. The instinct becomes fatal specifically in the context of a coordinated human drive hunt where the entire herd's movement has been deliberately directed toward a geographic feature that kills them. A situation no amount of individual bison intelligence could address effectively because following the herd is the correct individual strategy even when the herd is being collectively manipulated. The ground sloth, which ancient humans in North and South America encountered and hunted during the Pleistocene, provides another entry point into this discussion. Ground sloths were large, slow-moving herbivores with limited locomotor capability and behavioral profiles that ancient hunters in the Americas found, archaeologically speaking, not especially challenging to engage. Ground sloths were not cognitively sophisticated animals by most assessments. Being large herbivores whose ecological success depended on their size, their defensive capabilities including large claws used primarily for digging and possibly defense, and their ability to consume plant material that other herbivores couldn't process. Their cognitive complexity reflected the challenges their lifestyle posed, which didn't include sophisticated predator assessment of a novel bipedal hunter with projectile weapons. The woolly mammoth's relationship with ancient human hunters has been discussed extensively across multiple earlier videos in this series, but in the context of cognitive preparation for novel threats, the mammoth's initial responses to human hunting pressure across multiple continents where human contact was new may have reflected the same island naivety equivalent that occurs in large megafauna that have not previously faced an effective predator of a type. In areas where human hunting pressure was a novel introduction, megafauna may initially have lacked the behavioral responses that could have reduced hunting vulnerability before whatever behavioral adjustments were possible could develop within the population's remaining lifetime. Tortoises deserve attention in this discussion, because giant tortoise species on islands worldwide exhibited the same predator naivety as island birds and interacted with ancient human arrivals in similar ways. Giant Aldabra tortoises, Galapagos tortoises, and various extinct giant tortoise species that formerly inhabited multiple island systems, including Madagascar and various Indian Ocean islands, showed the same pattern of approach without flight, investigation of novel stimuli without threat recognition, and behavioral continuation in the presence of human observers that island birds showed. Giant tortoises were significant food resources for ancient humans arriving on islands where they existed, and archaeological evidence from various island systems shows substantial tortoise hunting in the early human occupation layers, followed by declining tortoise remains as populations were reduced. The cognitive situation of tortoises is interesting because tortoises have been around as a lineage for approximately 250 million years, which means tortoise cognitive programs have been tested and refined across an extraordinarily long evolutionary period. The tortoise strategy of withdrawing into the shell as a primary defense is ancient, effective, and excellent against most predators tortoises encounter in continental environments. It fails completely against humans who can simply pick up the tortoise and carry it away, or cook it in its own shell, which ancient and historical humans throughout the world did regularly and at scale. The tortoise's primary defense mechanism, which works against essentially everything in its evolutionary history, provides zero protection against the predation strategy that humans brought to the equation. Turkey vultures provide an entertaining entry into this discussion from a slightly different angle because vultures' apparent lack of sophisticated threat recognition and context produces interactions with humans that look cognitively limited but reflect a different kind of ecological optimization. Vultures that have learned to associate humans or human-modified environments with food access show reduced wariness around humans that, in the context of road scavenging, for instance, sometimes results in individual vultures being struck by vehicles while feeding on roadkills. The vulture is following a learned association between roads and food that is accurate most of the time, but the situation of a vehicle approaching at high speed while the vulture is focused on food creates a collision between accurate ecological learning and a novel threat that the vulture's cognitive system doesn't resolve effectively. Ancient humans who encountered vultures at kill sites found them competitors that were easily displaced through direct approach, which is a different situation from most large carnivores or even many medium-sized predators. The turkey itself is worth a brief mention because the behavioral profile that turkey breeders have produced through selective breeding, emphasizing body mass for meat production at the expense of other traits including cognitive capability and behavioral flexibility, has produced in modern commercial turkeys an animal with such reduced behavioral repertoire that they can drown in rain by looking up at it. This is entirely a human-created situation rather than a natural evolutionary outcome, but it illustrates how dramatically behavioral capability can be reduced when selection pressure for survival is removed and replaced by selection pressure for a single trait. Wild turkeys, the ancestor of commercial turkeys, are wary, intelligent birds with good predator recognition and reasonable behavioral flexibility. The commercial turkey is essentially wild turkey with most of its cognitive and behavioral diversity traded away for breast muscle mass, which says something interesting about what selection pressure actually produces in animal populations and what happens when it's removed or redirected. The broader pattern across all these examples points toward a consistent conclusion that reshapes what dumb means when applied to animals. Animals that appear cognitively limited in encounters with novel threats, particularly human threats, are typically animals that evolved in environments where that type of threat didn't exist, making behavioral programs for responding to it unnecessary and therefore not selected for. The apparent stupidity is actually the absence of behavioral programs for a situation the animal's evolutionary history never produced, rather than general cognitive limitation across the domains that actually mattered for the animal's survival in its evolutionary context. This matters for how we interpret ancient human encounters with cognitively naive prey. Ancient humans arriving on islands or in territories where their type of predation pressure was novel weren't encountering stupid animals in any absolute sense. They were encountering animals whose behavioral programming for dealing with novel threats was simply absent or inadequate for the threat ancient humans represented. The island birds standing still while being approached were following their best available anti-predator strategy. The giant tortoises retreating into shells were following their best available defense. The moas standing in clearings were doing exactly what moas had always done when large bipeds appeared in their environment, which before human arrival had been exactly nothing, because no such bipeds had ever appeared. Ancient humans interacting with these cognitively naive animals would have recognized the absence of flight response as a practical opportunity rather than as evidence of animal stupidity in any conceptual sense. Ancient hunters encountering animals that didn't flee were hunters who didn't need to spend significant energy on pursuit, stealth, or ambush, dramatically reducing the effort and risk associated with food acquisition. The practical implications of encountering island-naive animal communities were significant for ancient Pacific Island peoples specifically, for whom the behavioral profile of island bird populations was a recurring and practically important feature of new island colonization. What this entire survey ultimately reveals is that intelligence in animals, including the intelligence of recognizing and responding appropriately to threats, is not a property that exists on a single scale from least to most, but a collection of capabilities calibrated for evolutionary challenges. The most cognitively sophisticated bird in the world might still walk calmly toward a human with a net if it evolved on an island where no such interaction had ever occurred in its evolutionary history. The simplest seeming animal in a continental environment might have exquisitely calibrated predator recognition responses to every threat it has co-evolved with over millions of years. The dumbest animal ancient humans ever encountered was not dumb in any meaningful evolutionary sense. It was simply in the wrong place, at the wrong moment in history, when the one type of threat it had no behavioral program for finally arrived. The MOA in that New Zealand clearing didn't lack intelligence. It lacked time. Several million more years of co-evolution with human hunters would presumably have produced moas that fled from humans at considerable speed and were much harder to catch. That's how evolutionary arms races work, and how every prey animal that still exists in areas of long human habitation has been shaped by exactly that selection pressure. That Moa just didn't get those millions of years, and what looks like stupidity was actually the absence of enough time for selection to catch up with a novel threat that arrived and applied its full effect in geological terms approximately instantaneously.